So frequency is 50 hertz.
Right, correct. How did you find? Omega is equal to 2 pi hertz, right? Right. Omega is 340. Correct. 50 hertz. Yeah, I mean,
Resistance is 5 ohm.
tell me.
So resistance.
Just a minute. Which one? In this, you want the first question, resistance you wanted?
Yes, sir. Like I got 5 ohm resistance.
Okay, okay.
VM is equal to IMR.
Okay, let me just check. Resistance, right? Resistance is not 5 ohm, right? It is different. Something else you'll get. How did you find the resistance? Did you do V by I?
Yes, sir.
V by I will not give resistance, right? In AC circuit will give impedance. So that 5 ohm, what you have got, that's not R, that's Z.
So
Correct?
VM by IM.
Right, Vm by Im will give you the impedance.
Okay.
In case of pure resistive circuit, the imaginary parts of impedances are zero, right? So you will be left with only pure resistive elements in DC circuit. So in DC circuit, you could say V by I is equal to R. Whereas in AC circuit, along with resistance, you may have inductive reactance as well as capacitive reactance. So that can give you an impedance, right? So what you have to do here is that you have to take Z as say Vm by Im, as you said. So 100 by 20 will give you 5 ohm impedance. So that you take it as Z as 5 ohm. And then you can think of making use of the angles. Pi by 4 radians, right? When you convert it to degrees, how many degrees do you get? 45, right? So voltage will have a phase of minus 45 degrees and current will have a phase of uh, minus 1.5708 radians. You convert this 1.5708 radians into degrees. So this one. So you convert 1.578 into degrees. You should get 90 degrees here. And try to plot the vector diagram. So if you look at the solution, what you get is something like Z first, as you said. So Z is V by I, correct. So it is 100 by 20. That is 5 ohm. So that is your Z. Now what you can do, now you can think of drawing the vector diagram. So before drawing the vector diagram, what you do, first you find out pi by 4 is equal to how many degrees? So pi by 4 is equal to 45 degrees, right? Similarly, 1.5708, right? 1.5708 corresponds to 90 degrees, right? And now you can draw the vector diagram to find out the angle between voltage and current, right? So by finding out the angle between voltage and current, you will get the phase angle. And also by checking in the vector diagram which entity leads the other. For example, whether voltage is leading the current or current is leading the voltage. You can comment on the type of the circuit, whether it belongs to RL category or RC category, correct? Because in case of RL circuit, voltage should lead. In case of RC circuit, current should lead the voltage. So that you can find out. So for that, what you can do is you can just draw the vector diagram, take some, let's say, reference x-axis. Okay, I'll just draw reference axis, x-axis, and this is my y-axis. And then let me draw my voltage, right? So maximum value is 100, and the phase of voltage is minus 45 degree, correct? Minus pi by 4 is minus 45 degree. So what I will do, I will draw a line with length Vm, which corresponds to voltage. So here I'll write Vm at an angle minus 45 degree. Okay, that's my Vm. And then I have my current equation. Okay, it says maximum value of current is 20. And what is the phase? 1.57 radians, which is equivalent to 90 degrees. So my current axis going to be this. Okay. So let me just draw it with a different line. Slightly, let me thicken it. Okay, fine. So this is my current. So this one. So I am at an angle. How many degrees? Minus 90 degrees, right? Minus 90 degree. Done? Okay. So this is drawn at 45 degree. Okay. So this is drawn at 45 degree. And the other one is drawn at 90 degree, correct? This one. So this is drawn at 90 degree, the second angle. Okay. I'll place it here. Okay. Now you tell me, okay, this I will change it to red color so that you'll be able to understand the red color corresponds to current. What is the difference between Vm and Im? Phase difference. What is the phase difference between Vm and Im. Can anyone tell me?
45.
45 degree. Yeah. And what is leading what?
45.
What is leading what? When you
Voltage leads current.
always.
Current voltage is leading.
Right. So voltage leads current
That's correct.
by 45 degree. Yeah, 45 degree. So on that note, you can say the given circuit is RL circuit. Okay. So that should help you in solving the question. RL circuit. Once you have RL circuit, you can make use of something known as impedance triangle, right? So R is equal to, from the impedance triangle, we know that Z cos phi, and angle phi is equal to 45 degree. So that's nothing but angle between Vm and Im, right? So that's the angle between Vm and Im. That's what I'm writing. So you can find Z is equal to Z. You got it as 5 ohms into cos 45 degree. 45. Okay, that should give you symmetry. It gives basically 45 degree angle. 3.5. What's the answer? 3.53. Just check. And XL is equal to Z sin phi. So just check. You should get the same answer. 3.53 OHL. Once you know XL, you can find L. L is equal to XL divided by 2 into I into F. That should give you the L value. Just calculate and just let me know.
$11.2 millihenry.
11.2 millihenry. Let me just check. Yeah, 11.2 millihenry or 11 millihenry, correct. So R is 3.53 ohms. XL is 3.53 ohms. That's what I was saying. Whenever you get angle 45, you get perfect symmetry in your impedance. Okay, correct. So that is the first problem. Okay. All right, now you look at the second problem. $11 millihenry. Okay. Second problem, just so it says coil draws a current of 2 ampere when connected to 230 volt 50 hertz supply. The power taken by the coil is 100 watts. Calculate resistance and inductance of the coil. So problem 2. It's a straightforward problem only. Current is given. Circuit current is given 2 amperes. Voltage is given 230 volts. And power value also is given. So having known power value, one can estimate the resistance, right? Because power is something that gets dissipated only in resistance, not in the reactance part, right? Either it is capacitive reactance or inductive reactance. Okay. So how will you go about it? Solution. So you can firstly find out the impedance V by I. Yeah. So you are being given with the voltage value, which is 230 volts. So it's 230 divided by the current 2 amperes. So 115 ohm. So that's the impedance. And then you can find out current, resistance. Current is given, right? Resistance. So power probably you can take P is equal to I square into R. So you can basically so P by I squared. So you have been given with the information that the circuit is a coil, right? So coil means it is always RL circuit. RL circuit. So you can find XL value. So XL is SQRT square root of Z square minus R square. Okay, so calculate and just share your answers. So the question is to find the resistance and inductance of the coil. Right, resistance we have already found 25 ohms. You are supposed to find the inductance. How much you'll get? XL as 112.24 ohm. Just say. And then L value XL by 2 into 5 into, yeah, correct.
Point 3573.
Okay, 0.3573
73.
Henry. Henry. So that's your second problem. So on Tuesday, I will conduct a quiz on single phase AC circuits. Okay, not the three phase, only single phase AC circuits. Okay, so please be prepared. I'll ask about 10 questions. MCQ based quiz. Then problem 3. Right. So what it says, two circuits with impedance. The impedance values are given 10 plus J15 and 6 minus J8 are connected in parallel. And if the supply current is 20 ampere, what is the power dissipated in each branch? Okay. Yeah, so trying to find out. If you have any suggestions regarding the course delivery, you feel free to express, okay? Because it's a virtual teaching, so I will not be able to understand your emotions. Okay, in face-to-face interaction, I can always understand, by looking at the face. Okay, fine. Are you understanding or not? Here, I'm not able to do that. So, it's basically the input should come from you. So, if you have something to share, you can share it in the classroom itself, or you can, message me. Okay. So, if you want me to change my teaching way, that also you can tell me. Okay. Don't worry about what I feel or something. Okay, nothing else. Okay, I'll be taking it as the input from your side. So feel free to express your views regarding the content delivery. All right. Did anyone solve the third question? So I1 is 11.45. Doesn't matter. Few of you may get I1, 11.45 as I2. So don't worry. That's the magnitude of current I'm talking about. I1 is 11.45 and I2 is 20.64. So in problem number 3, I1, okay, what I can do is I can apply current division rule, I into Z2 divided by Z1 plus Z2. Right. So that will give me I1. So I1 is equal to 11.45 amperes. Okay. There is angular part also. And I2, you can once again apply current division rule, or you can just subtract I1 from the main current. So I2 is basically main current I, okay, which is given as 20 amperes, okay, minus I1, okay, I1. So magnitude and angle. You need to consider. So I2 magnitude, you will get it as 20.64 amperes. Just check. Okay. So having known I1 magnitude and I2 magnitude, you can calculate the power consumed in say branch 1 and branch 2. Let's call P1 as the power consumption in branch 1 and P2 as power consumption in branch 2. So P1 is I1 square, right? So cap 2 into R. The resistance of the first impedance you will consider while calculating P1. And I2 you can, power 2 can be found as I2 square into, okay, let's call R2 and R1. Okay. So that's 11.45 into 11.45 into R1. So R1 is 10 ohm and R2 is 6 ohm. So here you have 10 ohm and here you have 6 ohm. And I2 is 20.64. Okay. Did anyone calculate? Okay, just check if you get answers, close to this particular value. That is also fine. Can anyone confirm whether you got this answer or not?
So I'm getting 1311.02 and 2556.
That's okay. That's okay. That's okay. Small variation is fine. You're getting 1311 watts, right? And 2556 watts. Just 1 watt and 2 watts of difference. That won't be an issue. Fine, it is. Okay. So that's about problem number 3. And problem number 4